Well, here we are. Welcome back. We're now at worksheet 9B. In the next preview assignment and in the next class, you're going to need to be able to solve proportions using similar triangles and use the formula of interpolation to find unknown values in a linear relationship. So we're going to start with similar triangles. Remember, you're supposed to be keeping up with a glossary or flashcards or some form of vocabulary. And so here's a very important word to put down. Two triangles are called similar. They are similar if all three angles of both triangles have the same measurements. Think on that for a second. All three angles have the same measurements. When two triangles are similar, their corresponding side lengths are proportional. That means you can take a side, put it with a side, another side with another side, and you can solve all sorts of stuff. So question 1, assume the following pairs of triangles are similar and have side lengths as indicated. So part A, which side lengths correspond to one another? If you haven't paused the video and worked this problem first by yourself, you need to do that, and then come back and we'll work it together. Part A, which side lengths correspond to one another? And the cool thing is that we can go multiple directions, but it can also be a confusing thing. But the part we are going to note is that corresponding means like a hypotenuse. This is a hypotenuse side across from the right angle to a hypotenuse. Those are corresponding. That means they go together. And this is like the bottom or the base of the triangle. And so it's going to go with the base of the other triangle. We have a large triangle, we have a small triangle, and we have corresponding parts like the 5 and the 2 go together, and the 12 and the x go together. Write the ratios for the two bottom sides and the two hypotenuses. And so the ratio can also be very cool and very confusing. A ratio can be like 12 to x. And the hypotenuses can be 5 to 2. But you're not bound by that. You could also write the bases or the bottoms as x over 12, and you could write the hypotenuse as 2 to 5. Either way is going to be great. You're just going to have to find a pattern and be consistent. So looking at part C, I'm going to leave this drawing up there. In order for these triangles to be proportional, the two ratios need to be equal. In other words, equal are equal. Write an equation indicating that the two ratios are equal. And note that it's very important that the values of one triangle are in both the numerators and the denominators. In other words, don't do some crisscross stuff. Just keep it consistent. Keep the same pattern. Like, if you want to say hypotenuse of small triangle to hypotenuse of large triangle, hypotenuse of small to hypotenuse of large, then you must follow the pattern and say base of small to base of large. We kept our pattern. We didn't go right to left and then left to right. We stayed consistent. Once we have our equation, it says then solve it, or our proportion, solve it, and then write a sentence about our answer. So remember, this was hypotenuse to hypotenuse, bottom of or base of the small triangle to the base of the large triangle. To solve these, we are allowed, because we have one fraction equal one fraction, we are allowed to multiply those parts together and set them equal to the other parts multiplied together. We can then solve for x, creating a 1x over here, and then we'll grab our calculator and we'll punch in 2 times 12 equals, and then divide by 5. And so what I'm getting on my screen is 4.8. In other words, if these are proportional triangles or similar triangles, the sides will be proportional and we can solve fairly simply for the other side, which is the small triangle. So now let's keep going with question 2. Again, hit pause if you haven't tried this on your own. Do this question by yourself, and then let's come back and work it together. It says, assume that the following triangles are similar. And remember, by definition, it means their angles are all equal and their sides are proportional. Set up an appropriate equation and find the missing length and round to the nearest hundredth. We can also, well, what we did a while ago is we went like left side to left side, bottom to bottom. We can also set up a proportion where we stay on the small triangle and do left side to base equals left side to base. Again, it doesn't matter, just don't do like crisscross and backwards, and don't do this. Stay with a pattern. How about we get rid of that? Undo, 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 undo. So staying with the pattern, I'll do something, I'll go ahead and stay with what I did a while ago. I'm going to stay with the blue parts, and I'm going to say 8, the left side to the left side is the same as the bottom to the bottom. I have a proportion. With the proportion, I'm allowed to say that 8 times 14 is the same as 3 times x. I divide by the 3 so that I get a 1x over on the right. I grab my calculator. I type in 8 times 14 equals and divide by 3 equals. And the number I'm getting is x is about 37.333, etc. And they want us to round to the nearest hundredth. And so that means tenths, hundredths. I look at the 3 behind it, and it says that my value is 37 point, and it's 37 and 33 hundredths. So the nearest hundredth, right? So the same thing for question 3. If you haven't already tried it, I need you to go ahead and hit pause, go try it, and then come back and we'll work it together. If 2 things are in the same place at the same time, like a pole and a tall building, then their shadows will create similar triangles. And hey, if we've got similar triangles, we've got proportional sides, we can solve some stuff. Suppose you want to confirm the height of the Statue of Liberty in New York City. While it's going to be difficult to directly measure the height of the statue, you can measure its shadow on Liberty Island at a given time of the day. And we find out, and so I'm going to even draw a picture because that's very helpful, Lady Liberty on her pedestal there. And so the shadow is 122 feet. And at the same time, you notice there is a 5-foot pole. This is 5 feet tall, and it has a shadow of 2 feet long. I did not draw that very proportional or to scale at all. And so looking at these 2 drawings, they're really right triangles, and they'll be proportional. Having said that, at the same time, that is 2 feet long. Use the given information to write a proportional equation to solve for the height of the statue. So just like we were doing earlier, we want to know the height of the statue. We just need to be consistent with whatever mathematics we're doing on our proportionality. So now that we have a drawing, we can set up a proportion. And it's going to go crazy again. So here we go. Undoing, undoing. And sorry, let me get started here. So to set up our proportion, I'll go ahead and take the height of the big triangle to the height of the small triangle. And I'll put the base or the shadow of the big triangle to the shadow of the big triangle. Let's try this again. The shadow of the large triangle to the shadow of the small triangle. Remember that once we do this, we have permission now that we can say 2 times the x is the same thing as 5 times the 122. We'll divide both sides by 2 so that we get 1. and our x's worth, grabbing our calculators, I'm going to type in 5 times 122 equals, and then divide it by, 5 times 122 equals, divide it by 2. When I divide it by 2, I get 305, and that would be the height of the statue, so 305 feet. So then the bottom of this asks, what is the height of the statue? And we're saying it's 305 feet. And does your calculation confirm the published height? And yes, the statue and the base are 305 feet. So just a side note, it is always good when you're taking any kind of test or working on any kind of homework to have ways to double check yourself. And so if you're telling me that the x is 305 feet, we should be able to replace the value that we just found into our original proportion. And if we have written something wrong, we could still have wrong answers, and we might even want to rewrite these a different way. But a quick double check is to take these two numbers and multiply them. Take these two numbers and multiply them. In other words, we can go back and do our 305 times 2, and we get 610. And we can take our 122 times 5, and we get 610. Whoops, that's going to be feet, or just 610. And with these being equal, it tells us that we've most likely have a correct answer. Again, there could be some errors that we do have, but being able to plug this back into where we had it in our proportion is a good way to double check our answer. So not to scare you, but since we're doing a problem on the Statue of Liberty, here's me. This was me this summer with my daughter, stepdaughter, and mom. And this is me taking a selfie with my goofy glasses at the base of the Statue of Liberty. And who knew? She and the pedestal are 305 feet. This is a good time that if you haven't already done question 4, go ahead and hit pause and do question 4. Marta works in a print shop at a university. One of the accounting professors would like a life-size version of a tax return printed and mounted. In order to prevent distortion, everything's got to be the same, which means, because of similar triangles, the side lengths of the original tax return and the blown up must be proportional. So we have the original tax return. And remember, drawing a picture is really good to help your brain get adjusted, oriented to whatever's going on. And I just did this wrong. So let me go ahead and undo this. It says the tax return, original tax return, is 11 inches tall and 8.5 inches wide. The professor wants the blown up version to be 72 inches tall. And the question is, I think it's going to say, what's going to be the width of the blown up version? And round your answer to the nearest hundredth. Again, we have proportional, and it says it's based off of triangles, and so we could even just look at triangles this way and go, oh, there's a triangle. And so we need to set up a proportion, and we can do something like this. We could say height of the small, or the original, to the base of the original is the same as height of the life size to the base of the life size. Once we have this set up, we are allowed to multiply 11 times x, 8.5 times 72, and then we're going to divide by 11 by 11 so that this becomes 1. So I'm going to grab my calculator. And on my calculator, I'm going to hit clear a couple of times and then do 8.5 times 72 equals, divide it by 11 equals, and I'm getting as an x that it is about 55.636363. And if they want us to round to the nearest hundredth, then it's 6363. And that means my hundredth is right there. I'm going to look at the 6, and my x is about 55 and 64 hundredths inches. So the base of our life-size tax form will need to be 55.64 hundredths inches. The last part of this lesson is to become familiar, or to begin to familiarize ourselves with the linear interpolation formula. This is going to be in the preview assignment and the in-class activity, and it's got a lot of parts and it has a lot of variables. We're going to use this to calculate the price of a mid-size suburban utility vehicle. For right now, we're going to examine the parts and we're going to practice using the formula so that when you get into class, it makes it less intimidating. Linear interpolation formula is the following. And so it's just a bunch of y's, it's just a bunch of x's, and then we have a lot of subscripts with a's and b's, and we know order of operations. We'll be able to put together anything that we have in our in-class or practice or preview. But what you do need to note, and this definitely needs to go on a glossary or flashcards or something, that the variables are going to come from 2 points. And we're going to call one set of points x sub a and y sub a. And you'll notice that there are x sub a's in the formula, and there are y sub a's in the formula. And you're going to note that there's a second point that's x sub b and y sub b. And those aren't in there as frequently, but they're in the formula. And then there's going to be what we'll call an intermediate or middle point. And it's just going to get called plain x, and look, the y out front. The formula is written with an assumption that we know the x value of the intermediate point and that we want to calculate for the y value, that we know this value and that we're calculating for that value. So let's play around with this linear interpolation formula for just a bit. Remember, it said we're going to know 2 known points and an intermediate point. Remember, when we've been doing slope, I always label everything, and I want to go ahead and do the same here. Where I normally would go x1, y1, I'm going to go x sub a, and I'm too far up. It's not going to let me write up there. So let me undo this and go ahead and call this x sub a and y sub a. It's not going to matter how we label them as long as we don't crisscross the a's and the b's. Like right here, I'm going to leave this one x sub b and y sub b. Remember, it told us we're going to have 2 points. There they are. And the intermediate point's just going to be plain x and plain y. We'll be given the x and we'll be solving for the y. So, part A, what number will represent x sub a? Well, the way I have it labeled, it would be 4. But if you were doing this and you chose to label them, let me go ahead and do it. If you chose to label them like this, here we are, then you would have that your x sub a would be represented by 12. And I'll keep going back and forth. So what number is going to represent y sub a? Well, the first way I labeled, it would be this number. But if you chose to label a different way, then it would be this number. It's really okay. We just got to be consistent whichever way we are choosing to label with our a's and our b's. And then it says what number is going to represent x sub b? Well, the way I chose to label would be a 12. Uh-oh, trying to stay with my colors here. Uh-oh, killed the 3. So the way I chose to label my numbers, my x sub b would be 12. But if you chose to label differently, then yours would be 4. But you'll see how we still have all of the same numbers going on. And finally, on the y sub b, mine would be 4913, unless you chose to label differently, then yours would be the 12825. But all of these numbers over here are the same ones represented over here. We just need to keep them all in order and keep them straight. What we're about to do next, I'm going to use what I wrote in green to be the numbers that we use the rest of the formula. So looking on to part E, it says what number will represent x? Well, we get one choice on that one. X is going to be 7. That is our intermediate point. Moving on to parts F and G. They want us to substitute each of these, but do not perform any calculations. And then part G, we're going to do some order of operations and actually calculate for Y. So just taking it very nice, easy, slow. So looking at part F says let's take the whole formula and let's plug in the information. And looking back at the formula, it's pretty large, but if you just start looking at it piece by piece, it's really very doable and very manageable. So the formula looks like this. You do not have to memorize this formula for this class or your 1332 class, but you do have to know how to plug in numbers, figure out which numbers go where and plug them in, and solve for the Y. So using the numbers that I have selected, I'm going to say that my Y is, and always write down your formula. What is my Y sub A? Well, here's my Y sub A. I'm going to use the 12825 minus. Now on the Y sub A, oops, there's another one, 12825, and I'm running out of space. Sorry about that. Minus Y sub B, and that's going to be the number down here, minus 4913. Over here, my X is 7. My X sub A is 4. The bottom part has, let me double check because I can't read my writing now, X sub B. And so for that I put 12 minus X sub A. This is part F. And then G says, let's go ahead and solve this. This might be a good time to hit pause and go back and rewind and look at this piece and parts and where's everything coming from. Because if you used all the information in purple, yours will look different, but in the end, you and I will still get the same number. So to do part G, it says, let's work this out very slowly. So I'm going to grab my calculator and I'm going to type in what I have in the first parentheses. Because remember, order of operations says do whatever you have inside parentheses first. And I have 12,825 minus 4913. And I get 7,912. So I worked inside that parentheses. And then here, I'm going to get 7 over 4, which is, or 7 minus 4, which is 3, and 12 minus 4, which is 8. So now, order of operations says if I can multiply or divide, I should do that next. This is a minus. It's going to come at the very end. So I'm going to put these together by multiplying top times top and then dividing by 8. So I'm grabbing my calculator and I have 7,912 times 3 equals. I'm going to divide it by 8 and it equals. And so I'm getting 2,967. I am now allowed to subtract. So I have 12,825 minus 2,967 and I'm getting a final answer of 9,850. Oh my gosh, 50. Oh, I'm so close to the edge, it doesn't like this. 9,858 is a final answer. With that in mind, if you want some more practice, you can go back and take all my numbers in purple here, plug them in to the formula, then work through the formula, and when you get 9,858, you've got a lot going for you as you go into your next class dealing with learning the linear interpolation formula. This finishes our lesson 9B. Look at your calendar, see if you have more to do for this week. If not, you're done. Finish this up, get it uploaded to D2L, and we'll see you with more assignments when I upload them late Friday night.